Okay, hello everyone. Let's go ahead and take a look at section 22C.1. And this is about general rates of change. Now in the previous section we've talked about rates of change with respect to time. But it doesn't always have to be with respect to time. It can be with respect to anything. So what we want to do then is we really want to try to generalize. And the easiest way to generalize is to not be particular about the function. Like say for example in this case we talked about the distance function. Let's just talk about any function that we can possibly have. And of course the usual values or the usual variables that we use are x and y. So let's generalize then and talk about y being equal to the function which was -1 plus the square root of x. Okay? So if we generalize about this, then we can generalize about all the other types of different specific functions that we have. So let's go ahead and take a look at how this applies to calculus and the general rates of change. Okay, what we really want to focus on in this particular section is the relationship between the slope of the function, the instantaneous rate of change, or the slope of the tangency line of the function, and what's happening with the function. Okay, so let's go ahead and just get an idea here. Let's take a look first at the possible values of slope. Okay, now if I was to go ahead and use this line, this rubber band here, to describe the slope of a particular line. Now we know that this slope here, if I go this way, that's a positive slope. All of those are positive slopes. That's going to be a zero slope. And then of course if we go this way, that's going to be a negative slope. So it seems that for any particular function, there's really three different categories for our slope. We can either say that the slope is positive, is greater than 0, right? It's positive. The slope could also be less than 0, which is negative, or it could actually be equal to 0. So let's just go ahead and take a look at that again. Let's use the rubber band. If we're talking about a positive slope, then that means it looks like this, right? That line has a positive slope. If we talk about a line that has negative slope, then we're talking about this. If we're talking about a line that has zero slope, then we're talking about a horizontal line like this. Okay, so what that means then is we have to now go ahead and take a look at the function here that we have, which is f of x is equal to -1 plus the square root of x. And we want to take a look at the slopes and what is happening to the slopes. Okay, so let's just go ahead and start here. If I was to go ahead and take a look at this here, the slope looks like it's about there, the tangency. Looks like it's positive. If I was to go ahead and talk about the instantaneous rate of change of that, there's the tangency line, that's also positive. If I go over here, the slope of the tangency line is also positive. It looks like the slope is going to be positive for any particular value of x that we have, for this particular function, of course. So what that means then is that for this function, all of the slopes are greater than 0. Now, what does that mean with regards to the function itself? Okay, here's all the possible values of slope. What is happening to the function? Okay, what is the function doing? Well, if we just go ahead and take a look at what's happening here, it looks like the function, the y values of the function, okay, the y values, as we go from left to right, well, we start at -1, we go to 0, then we go to 1, and we keep on increasing. So notice what happens then is that if we have all the instantaneous rates of change of your function being greater than 0, then that means that the function is tending to increase. Okay, so in other words, the function's increasing this way. Now, of course, what's happening when, say for example, if the slope is negative? What happens to the function? So let's go ahead and erase this one here. Let's just use that as a starting point. And let's draw a more radical function. Now, we're not going to associate it with any particular function itself in terms of an equation, but let's just go ahead and draw something a little bit more radical. Okay, so let's just go like this. Okay, that's a nice function. Let's say that that continues on and that continues on. Okay, so let's just go ahead and play with this again, and let's try to analyze this function just by looking at its slopes and what's actually happening to the y values of the function. Okay, so if I was to come over here, here's all my instantaneous rates of change. Instantaneous rates of change. Notice that all of these slopes, all of the slopes of the tangent line are all positive, and then all of a sudden it gets to here. That, of course, the tangency line has a slope of 0. Okay? And then if we go down this way, all of a sudden, the slopes are actually now decreasing, or sorry, I should say the slopes are actually negative. And then all of a sudden we get back down here, and then it looks like again the slope is going to be at 0. After that, the slopes again start to be positive again, and it continues that way. So if I was to just go ahead and take a look at the slope, and I'm going to do this in green. If I was to put plus or minuses or 0, right, to mean positive slope, negative slope, or 0, this is what it would look like. Okay, here all of these values are all positive, positive slopes, positive slopes, positive slopes, and then all of a sudden it gets to here. And then at here, I'm going to draw that, because that's actually going to tell me that the instantaneous rate of change at that particular point, at that particular time, a point, let's say point, is going to be 0. Okay, we know that the slope is 0. After that, it starts, the instantaneous rate of change is negative because we looked at all the slopes as it goes this way. And then again, once it gets to here, the slope is 0. Again, then after that, once I go past that point, again notice that my instantaneous rate of change or the slope values of all my tangent lines are all positive. Now, let's go ahead and associate now what's happening in terms of f of x and the values of y. Now, we already know that if the slope is positive, let's just take a look at all those parts where the slope is positive. All the instantaneous rates of change are positive. Here, it's there. And it's also here. What's happening to the function? Well, the function is actually increasing whenever the slopes of the tangent line are positive. So it's always over here. The function is actually increasing. The function is actually increasing. Now, what's happening when the slope is actually negative? Well, this is the only area where the slope is actually negative. What's happening to the function as we read it from left to right? So if I start over here and I go this way, all of these values over here, all the slopes of the tangency lines are all 0, are all negative, which means that the function is, instead of increasing, it is decreasing. Okay? Now, what happens when it's equal to 0? Well, when it's equal to 0, here you go. Those where our tangent line is actually going to be horizontal, that way. Well, it's neither increasing or decreasing, right? It's neither increasing or decreasing, and usually what we do is we say that at that point, it is stationary, or a stationary point. Okay? And so there you go. That's how we want to go ahead and analyze now the relationship between the slope of the tangent lines and how the function is actually changing.